A Roman warship lies off the coast of Sicily in a dead calm. The sky is clear, and there are nearly 100 armed warriors on board. From the walls of the ancient city, no arrows, stones, or fireballs fly. Only gentle sunbeams slowly touch the canvas sail of this ship as it glides. First, a warm spot appears on the sail. Then a thin wisp of smoke rises. 10 minutes later, flames erupt, and the ship burns on the water. Without fire arrows, without catapults, without any of the usual weapons of that era. The Roman fleet commander doesn't know what's happening, so he orders battle formation. 20 minutes later, he gives the order to retreat. 60 ships turn away. This scene occurred near Syracuse over 2,200 years ago. She was taken care of by a man named Archimedes, the one who shouted the word Eureka. Archimedes died by Roman soldiers' sword, who didn't know whom he was killing. But this man's inventions outlived him by 22 centuries. Right now, as you read this, you're surrounded by 5 of Archimedes' discoveries. Each of them was at least 2,000 years ahead of its time, and the latter we are only now beginning to truly understand. Let's start with an invention that you can see today in any major city. If there's a water treatment plant in your area, it most likely uses an Archimedes screw. This is a spiral inside a tube that lifts water upwards simply by rotating it. Archimedes saw the beginnings of such a device during his journey to Alexandria, Egypt, but it was he who described the screw mathematically and perfected its design. This screw watered the fields along the Nile for 2,000 years. They drained the holds of ancient Greek ships and the mines of Roman silver. And in the modern world, it works where no one expects it to. In 2000, engineers faced the task of saving the Leaning Tower of Pisa from falling. The tower leaned more and more toward the ground, with its angle increasing each decade. All known stabilization technologies risked damaging its fragile medieval foundation. The solution came from the 3rd century BC, directly from Archimedes of Syracuse. They drilled holes on the tower's north side and put Archimedes screws inside. As soil was slowly removed, the tower gradually straightened under its own weight. The tower we see now stands thanks to an invention from 2,000 years ago. The Archimedes screw operates at Edinburgh Airport, directing rainwater away from the runways.
It spins in water treatment plants, where normal pumps would harm fish and algae. Chocolate fountains at weddings and restaurants work the same old way. Archimedes' screw powers clean, renewable electricity in countries with small rivers. Reverse action turbines turn propeller spin into safe energy for entire villages. In Scotland and Sweden, such systems power hundreds of homes in rural areas. The main advantage is that the screw is safe for fish caught in its twists. A regular hydro turbine would harm any fish caught in its blades, but the screw lets it pass unharmed. In Holland, Archimedes screws were used to drain lands now known as polders. Whole provinces in this country are below sea level because of an ancient invention. Without the screw of Archimedes, part of Europe would still be underwater. And the most amazing thing is that its design has barely changed over the centuries. 23 centuries passed. Computers, rockets, thermonuclear reactors appeared. The Archimedes screw still turns, lifting water from lower to upper levels. If this dive into engineering history interests you, subscribe to the channel. The next inventions will be even deeper, and each will make you think about our place. This is the first of Archimedes' 5 discoveries that still serve your daily life. The second thing you studied in school, unaware of who you owe it to. King Hiero II of Syracuse commissioned a golden crown for the Temple of Gods. When the crown was brought to the palace, the king had a dark suspicion. The jeweler could take some gold, replacing it with silver of equal weight. Melting the crown to check would destroy a temple offering to the gods. Hiero summoned to his palace his relative, known for his calculations and clever inventions. It was Archimedes, and the problem seemed completely unsolvable to him at first. Silver is lighter than gold for the same weight, so the crown will be larger. But how do you measure a complex object's exact volume without breaking it? Archimedes thought about it day and night for several weeks straight. A scientist went to a public bath in Syracuse to relax from a difficult problem. He sank into the overflowing tub, and some of the water spilled onto the floor. Most bathhouse visitors would simply ignore this mundane trifle without a second thought. But Archimedes paused and felt the water rise exactly as much as the space his body occupied. At that moment, the scientist had an insight that would change the course of human knowledge forever. The volume of displaced water equals that of the submerged object, regardless of its shape. The scientist ran naked through the streets of Syracuse, shouting one word. That word was Eureka, which, from ancient Greek, translates to the phrase, "I have found it." Hiero's crown was submerged in water, and measurements confirmed the suspected jeweler's deceit. The crown displaced more water than a pure gold bar of the same weight, exposing the trick. But this scene in the public bath led to something much bigger than just a revelation. Archimedes discovered the law of hydrostatics, now known to nearly every school child on Earth. A body submerged in a fluid loses weight equal to the weight of the fluid it displaces. This law is the foundation of every ship and every submarine on our planet. The ocean liner sails through the sea based on calculations made in Syracuse. Every mine when filling ballast tanks, every hot air balloon operates according to this law. Modern oil platforms are designed using equations directly derived from Archimedes' principle. Without this law, there would be no ocean fleets, no aircraft carriers, no deep-sea vehicles. A modern aircraft carrier weighs about 100,000 tons, like a small mountain. This floating mountain stays on water by the same principle as the Syracuse bathtub. Every cubic meter of iron that is submerged in water displaces an entire ton of liquid. And it is exactly this ton that lifts the ship, turning metal into a floating fortress. If you were in King Hiero's place, would you trust the scientist's calculations or demand to cut the crown? 23 centuries have passed since the bath in Syracuse, and the law still holds. But from peaceful discoveries, we move on to Archimedes' most frightening invention of all, to what official science called a legend, until modern engineers put it to the test in practice. Imagine you are a Roman legionary on the deck of a warship at the walls of Syracuse. Your captain says the attack will start in an hour, once the sun is up. You see dozens of bright golden dots lighting up on the city's fortress wall. First, you think it's reflections on Syracuse defenders' bronze shields. Then the points merge into a single focused beam that touches the sail of your ship. In a few minutes, the sail starts to darken, then it smokes, and finally, it truly catches fire. The ancient world had never seen anything like it until this moment. Historians Plutarch, Polybius, and Livy recount this episode, describing the siege of Syracuse. They describe Archimedes' mirrors, which directed sunlight to a single point on an enemy ship. For 1,500 years, scientists and philosophers doubted the reality of this weapon. They called this weapon a beautiful poetic invention of later Roman chroniclers. In the 17th century, René Descartes declared Archimedes' rays physically impossible. The great philosopher calculated and said there isn't enough sunlight to set a ship on fire. But in 1747, the French naturalist Count Buffon conducted his experiment. He used 168 flat mirrors and ignited a tarred board from a distance of 60 meters. Buffon published results, and the scientific community was silent for nearly a century. But in 1973, Greek engineer Ioannis Sakis took on the inspection. At the naval base near Athens, he placed 70 soldiers with bronze mirrors. Each mirror was 1.5 meters by 1 and pointed to a common point. At the focal point, there was a wooden model of a Roman ship, 50 meters away. A few minutes after the beams were focused, the wooden model indeed burst into flames. In 2005, students at the Massachusetts Institute of Technology replicated the experiment more cleanly. They used 127 square mirrors, each 30 centimeters wide. The wooden ship target at 30 meters caught fire after 10 minutes of precise focusing. The amazing thing is, the experiment works only in direct sun and on a still target. This matches Plutarch's description. Attacks came in the morning with the sun in the east. Syracuse is positioned so the attacking fleet faced directly toward the dawn east. Archimedes understood the laws of optics so deeply that he turned the morning sun into a weapon. Modern science has spent 2 centuries on experiments to prove what he applied in practice. An 8th grader from the American state of Ohio replicated the experiment in his backyard in 2020.
A student used homemade aluminum foil mirrors to light a piece of wood on fire 10 meters away. The history of science recalls few cases where a schoolboy manually verified ancient weaponry. What thought is more terrifying? That a lone old man made a vast empire's fleet retreat in fear? Or that our civilization is rediscovering knowledge from 2,000 years ago? But the most terrifying weapon of Archimedes I have saved for the next segment of this video. 60 Roman quinqueremes approached the walls of Syracuse under the cover of night in the year 214 BC. Each quinquereme was a 5-deck ship, about 40 meters long, with 200 oarsmen inside. This was one of the largest naval operations of antiquity, and Rome was confident of victory. Ships approached the walls in darkness, hoping to surprise the defenders at night. But Archimedes foresaw this too. Catapults of various sizes for different distances stood on the walls. Long-range guns fired heavy shells at the ships as they approached the city. As the ships approached, medium-sized catapults with short iron darts came into play. Polybius calls these small machines scorpions, and they shot through narrow slits in the walls. The attacking legionaries came under continuous fire, which did not let up for a minute. But the scariest thing appeared from the walls when the ship finally neared the harbor. Then, from behind the fortress walls, huge wooden beams began to emerge, visible in the torchlight. Iron hooks hung from the beam ends, slowly lowering to the harbor's black water. The hook caught the ship's bow and began lifting it straight up out of the water. First, the ship stood on its stern, like a buoy held by the ancient city's unseen mechanical force. The mechanism released the hook, and the ship plunged vertically into the water. The ship broke apart from the impact, or capsized, and hundreds of sailors sank to the harbor floor. It was the iron hand of Archimedes, or the claw of Syracuse, as the Romans themselves called it. Plutarch describes how, with the grappling hooks, large stones fell from the city walls, stones weighing 10 talents, which is approximately 300 kilograms of solid rock. One such shell, dropped from a fortress wall, easily broke through a ship's deck. The ship sank in less than a minute, along with everyone inside the hull. In 1999, the BBC conducted an experiment with a model of an iron claw. Engineers built a working copy of Archimedes' hand in 7 days, based on ancient descriptions. A 1/60th scale model of a quinquereme was overturned by this claw in a matter of seconds. In 2005, the Discovery Channel repeated the experiment live on a full scale. Again, the iron hand worked just as ancient historians described it thousands of years ago. Calculations showed that Syracuse could defend its port with 25 such mechanisms simultaneously. Each covered a section of the fortress wall about 36 meters long by the harbor. In total, this meant a continuous line of defense of nearly 1 kilometer of solid fire. Any ship entering the reach of the claws would be struck by several mechanisms at once. Roman sailors called Syracuse the City of 100 Hands, and each hand lifted a ship from the water. After the first night's attack, the Roman fleet lost most ships and had to retreat. The city fell only after 2 years, and only due to betrayal during the Artemis festival. An elderly mathematician from Syracuse held the largest military empire of his time with pure calculations. When the Romans entered the city, Archimedes was drawing geometric figures in the sand. He was about 75. He didn't hear the street cries or the clanging swords. General Marcellus ordered his soldiers to find Archimedes alive and bring him. The great mathematician was known throughout the Roman world, and Marcellus wanted to meet him. A soldier entered the yard and saw an old man on the ground, drawing in the sand. The soldier didn't know who he saw. He ordered the old man to rise and follow him. Archimedes didn't look up from his drawings, saying only one short phrase in ancient Greek. "Don't touch my circles," the old man said. The soldier, not understanding, stabbed him with his sword. When Marcellus learned of Archimedes' death, the Roman general bowed his head and wept before his troops. He ordered the mathematician to be buried with honors befitting a king or a high priest. Now imagine that this same person created something even more amazing during peaceful times. Not a weapon, not a pump, a machine that displayed the movement of all known celestial bodies in small bronze. The Roman general Marcellus, who captured Syracuse,
took only one thing from the entire devastated city. It was a mechanical bronze sphere that Archimedes had made for his own amusement many years ago. The sphere showed the movements of the Sun, Moon, and 5 planets visible from Earth. Mercury, Venus, Mars, Jupiter, and Saturn revolved in their orbits inside a small bronze box. When Marcellus turned the mechanism's handle, the sphere showed the entire night sky's movement. The solar and lunar eclipses on it matched the real eclipses in the sky over Rome.
150 years later, the Roman orator Cicero saw Archimedes' sphere in Rome. He described it in his treatise On the Republic with both admiration and disbelief. This Sicilian, according to Cicero, had more genius than human nature is capable of containing. For 1,500 years, this record was seen as poetic exaggeration, like the story of the mirrors. No one believed that complex gear mechanisms could have existed in the 3rd century BC. Precision mechanics wasn't thought to exist in Europe until the 16th century AD. But in 1900, Greek divers found a sunken ship near the island of Antikythera. Among the old wreckage, divers retrieved a bronze lump covered in thick limestone deposits. When the find was cleaned at the museum, geared cogs of astonishing precision were discovered inside. This item entered world science as the Antikythera mechanism of ancient times. The find is dated to the 2nd century BC. Just over a century after Archimedes' death. Inside, over 30 bronze gears were found, calculating the movements of planets and solar eclipses in advance. The front of the mechanism showed the sun and moon's positions in the zodiac on any day. Scientists decoded a separate dial that calculates the exact dates of the Olympic Games for decades ahead. Another dial predicted lunar and solar eclipses accurately to within 1 day on the calendar. The third showed moon phases and the positions of the 5 planets known in antiquity. The accuracy of the mechanism matches that of 17th century European timepieces, at the very least. The names of the months on the dial come from the Corinthian calendar used in Syracuse itself. Most researchers today see the Antikythera mechanism as a direct descendant of Archimedes' own sphere. A fine engineering tradition may have begun in Syracuse and lasted a century after the scholar's death. Then the mechanism crashed in open sea and vanished underwater for 2,000 years. Only recently have X-rays and CT scans revealed its internal structure almost completely. A British research project used an industrial tomograph to examine the metal fragments. The rays penetrated the calcareous crust and revealed the inner workings as seen by the maker. On the cogwheels, ancient Greek inscriptions were deciphered, describing celestial phenomena. Modern watchmakers long refused to believe in the authenticity of the find and its age.
They couldn't believe that such precise mechanics existed 1,600 years before European clocks. A British engineer, Michael Wright, built a working copy of Archimedes' sphere based on Cicero's description. Its reconstruction showed planet movements with amazing accuracy for an ancient bronze craftsman. Some gears of the Antikythera mechanism are still not decoded and hold their secrets. Scientists keep discovering new things about it every decade of research and analysis. Each new piece of gear reveals a new fact about what Archimedes knew of the sky. One group of scholars sees Archimedes as a typical genius of his time, skillfully combining existing ideas. Another camp believes it is 2,000 years ahead of its time, and we are just catching up. Share in the comments which camp you belong to and why you made that choice. 2,200 years ago, in a small town in Sicily, there lived a man. He had neither electricity, nor a computer, nor even paper that modern scientists write on. He drew his designs in the sand of the Syracuse beach with a simple piece of wood. These blueprints in the sand became the foundation of our plumbing and our fleet. They laid the groundwork for optics, military engineering, and celestial mechanics for centuries. Every aircraft carrier, every submarine, and even every chocolate fountain remembers this old man. Every eclipse predicted by modern astronomers was foretold in a small bronze box long ago. Every water treatment plant and every ship raised from the depths operates by his laws and calculations. A man who died by the sword of an illiterate soldier outlived all empires for 22 centuries in a row. Cicero wrote that this Sicilian had more genius than human nature was capable of containing. Maybe progress isn't about inventing something completely new and unseen before. Perhaps progress is the ability to recognize what was created long before us. And the next time you hear the word obviously in connection with ancient history, remember an old man with a piece of wood in his hand, drawing circles in the sand that remain unsolved.